Hi friends, welcome to my YouTube channel. Today I am going to start transformer theory class. Okay, this is your transformer theory class first. Okay, I am using NIMI second semester book. Okay, so in this video you can see what is transformer. Okay, I will teach you what is transformer principle and classification of transformer and EMF equation. Okay, I have given the transformer notes in the description box. You can see and write down the all the notes. Okay, first we will see. Let's start the class. This is the transformer theory class first. So first we will see what is transformer. In this video I will explain you what is transformer. So friends, this is the definition of transformer. Transformer is a static electric device which transfer the electrical energy from one circuit to other without changing the frequency and power. Okay, this is the definition of transformer. Okay, you can write down in the your notebook also. So if you remember this definition, today you will remember, tomorrow you will forget. Okay, to remember this definition permanently, I will teach you the techniques. Okay, see here how to remember the transformer definition. So transformer is a, up to here is completed, there is no doubt. Transformer is a static. Okay, what is the meaning of static? Okay, static means not moving. Okay, static means not moving. Okay, so transformer is not moving, transformer is not rotating. Okay, so we can say that transformer is a not moving electric device, right? Transformer is a not moving electric device. Okay, so up to here the definition is clear. Transformer is a static device. Next, which transfer the electrical energy. Okay, which transfer the electrical energy from one circuit to other. Here important point is electric energy. Okay, we have to know what is the meaning of electric energy. See here, electrical energy means, we know that energy means the ability to do work. Okay, what is the definition of energy? Energy means ability to do work is the definition of energy. We know that potential energy. The potential energy means stored energy. We know the kinetic energy. Kinetic energy means energy in motion. Okay, we don't know the electrical energy. Okay, so I will explain plus what is electric power. Okay, what is electric power? Electric power means the amount of energy used in a certain amount of time is called electric power. Okay, so definition of electrical power is power equals to energy, power equals to energy divided by time. Okay, this is the formula of electric power. This is very important formula. Okay, so therefore energy means power into time. Okay, this is the formula of electric energy. Power means we know that V into I is the power, we put it T as it is. Okay, electrical energy equals to voltage into current into time. This is the electrical energy. This is very important formula is there, you have to remember. You can see that after completing 1 month your electric bill will come. Okay, they said that you consume certain amount of electrical energy. Okay, that's why you have to pay the bill. Okay, this is the electrical energy. Okay, so this definition is completed. Up to here there is no problem. Okay, this is completed, right? See here, transformer is a static electric device, this is completed, which transfer the electrical energy. Electrical energy means I told you na, V into I into T. Okay, this is electrical energy. Okay, which transfer the electrical energy, sorry, okay, we transfer the electrical energy from one circuit to other. This is one point is there, circuit. Okay, I will explain this. Circuit means, we know that, what is the definition of circuit? Circuit means a wire starts and finishes at the same place, we say circuit. We know that our electrical circuit, one phase wire will come. Okay, this is the switch. Okay, we connect on a lamp and this wire is coming again back. Okay, this is open circuit. Now this is the closed circuit. Okay, this is the one circuit. Suppose this is a one circuit. Okay, and this is another circuit. Okay, means this circuit and this circuit, there is no electrical connection between these two circuit. Understand? So what transformer is doing, it transfer the electrical energy from one circuit to another. Okay, the energy means VIT. Okay, VIT, from this circuit to this circuit, the energy, the transformer transfer the energy from circuit number 1 to circuit number 2, means it transfer the voltage current into time from this circuit to this circuit. Okay, without changing power and frequency. This is very, very important. Okay, power and frequency is important. Okay, without changing power and frequency, these 2 points are very, very important. Okay, so this is completed the transformer definition. So you can say that, now I can say that transformer is a static electrical device which transfer the electrical energy from one circuit to other without changing the frequency and power is called transformer. Okay friends, now you can remember what is the definition of transformer. If you remember static, now the transformer definition will come. If you remember the electrical energy, you can remember the definition of transformer, right? If you remember the circuit, you can remember the definition of transformer. Like that, frequency and power. Okay, these are the key points. Okay, if you remember these points, you can remember the transformer definition. So next we go. Okay, this is the NIMI book. Okay, if you come down, this is normal, this is not important. Okay, so we come down. So this is two winding transformer. Okay, this is important. Okay, in two winding transformer. So in two winding transformer, what we have to learn? Okay, in two winding transformer, we have to learn what is primary winding, what is secondary winding, right? Next, what means primary winding, what is the function of primary winding, or we can say that what primary winding will do, right? Next, what secondary winding will do. Okay, these 2 points we will see. Okay, first we will see what is the definition of primary winding. Okay, I will give the notes in the description box. You no need to worry the writing the definition. First you have to understand the concept. Okay, what is primary winding, what is secondary winding, okay, what primary winding will do, what secondary winding will do. If you clear the concept, then it is useful for you. Okay, let's start first. What is primary winding? Okay, what is primary winding? So friends, primary winding, I will tell you the number of definitions. Okay, first you will see here, we will start from here. Okay, this is the AC source. Okay, this is the AC source. This is very important point. Okay, don't, what happen if it is a DC source? Okay, if it is a DC source, what will happen? The transformer will burn. Okay, so to avoid the burn, so what we'll do here, you put a AC source. This is key point number 1. Okay, second, the supply terminal. Okay, means this is the input. Okay, we can say that this is the input. Next, so what is the input for the transformer? AC source, supply terminal. Okay, this is the input for the primary winding or primary transformer input. Transformer input is AC source. This is very important. Okay, this is completed. Transformer input is AC source. So we have given the AC, so the current is flowing into the primary winding. Okay, so what is primary winding? Here the definition, what is primary winding? Okay, primary winding means the current flowing in the coil connected to the AC source is called primary winding. Okay, see here. What is primary winding definition? Primary winding definition is the current flowing in the coil. See, this is the current. Okay, the current flowing in the coil which is connected to AC source. Okay, this is the AC source. Okay, is called primary winding. This definition is clear. What is primary winding? The current flowing into the coil which is connected to AC source is called primary winding. This is clear. Next is, what is secondary winding? Okay, this is the secondary winding is there. So what is secondary winding? I will explain. See here. Here the primary winding is connected to AC source, that's why this is a primary winding. The secondary winding is connected to the load. Okay, see here. Okay, the secondary winding connected to the load terminal. Okay, the winding, this is the winding which is connected to the load terminal is called secondary winding. This concept is clear. Okay, this is very important, right? What is secondary winding? The winding, this is the winding which is connected to the load terminal is called secondary winding. Okay, next, what secondary winding will do? Okay, what secondary winding will do? The secondary winding supplies the power, supplies the electrical energy to the load terminal. Okay, we know that what is the load means? Load means the electrical component that consume the electrical power. Okay, we say load. Okay, this is the definition of load. This is very important. What is load? Load means electrical component that consume electrical power. Example, motor, TV, fridge, light, etc. fans. These are the load. Okay, so this is the what secondary winding will do? It supplies the power, it supplies the electrical energy to the load terminal. Okay friend, this concept is clear. What is primary winding, what is primary winding and what is secondary winding? These two concepts are clear. Okay, I will see the one more concept. Okay, one more concept is flux. Okay, this is completed. Okay, see here, primary winding, secondary winding, these are completed. This is the book. Okay, whatever I say here, from here only. Okay, this AC source, all these are these are definitions I have taken from here only. Okay, so here one more concept is there. I will clear this concept. What is that? it set up the flux in the core which varies periodically. Next we will see. Okay, this point is there. Okay, if I clear this point, we can go to the next definition. Okay, magnitude and direction. The flux link the secondary coil called the secondary winding or simply secondary. The flux is changing, therefore it induces a voltage in the secondary by electromagnetic induction. Thus the primary receives its power from the source while the secondary supplies the power to the load. Okay, this action is known as transformer action. Okay, there is no electrical connection between these two coils. Okay, I will explain these points in simple form. Okay, whatever I have noted here, I will explain this point with the help of this figure only. Okay, see here, this is the primary winding, this is our input source. Okay, when the current enters into the primary winding, it set up a magnetic field. Okay, it set up a magnetic field like this. Okay, see, this is the magnetic field. Okay, this is the magnetic field. Okay, so you get the point now, right? When the current is passing through the primary winding, it set up a flux. Okay, this is the flux. Okay, this is the flux. It set up a flux. Okay, the flux is linked to the secondary winding. Okay, this flux is there, it links to the secondary winding. So here also flux is set up. Okay, here also flux is set up. Okay, see here flux is coming here also. Okay, this flux, it induces a voltage here. The voltage, primary winding to secondary winding, the voltage is coming here. So we can say that when we pass the current in the primary winding, it set up a flux. This flux linked to the secondary winding, it induces a voltage in the secondary. Okay, this voltage supplies to load terminal. Okay, this action we say that transformer action. Okay, what I have said here, see here. Okay, this is the transformer action. Up to here this is completed. Okay, this is completed transformer action. Okay, next, transformers are usually made to change the voltage level. Transformers are efficient because the rotational losses are absent. Okay, see here, I will tell the one more important point here. Okay, transformers are efficient because the rotational losses are absent. This is very important point. Okay, why important, I will say that. The question will ask in the exam why transformers are, okay, why transformers are having higher efficiency. Okay, this question will come in the exam. Okay, why? The reason is, what is the reason why transformer having the higher efficiency? Because rotational losses. Okay, this is a very important point. Okay, rotational losses. Okay, rotational losses are absent. Okay, rotational losses are absent. This is the point, absent. This is very important point. Okay, why transformer having higher efficiency? Because rotational losses are absent, mean because transformer is a static device. Okay, static device means not moving. Okay, this is not moving, that's why the transformer having higher efficiency. Okay friends, this point is completed. This is very important point. Okay, next we will see Okay, little loss to which in the transformer from one voltage to another voltage. Typical efficiency. This is next. This is the second point. What is the second point is, see here. Okay, the the efficiencies are in the range of 92 to 99%. Okay, this question will come in the exam. What is the efficiency of transformer? Okay, you have to tell 90, 92 to 99%. Okay, 92 to 99% is the efficiency of the transformer. This is very important point. This point will come in the exam. Okay, these 2 points are clear. Next we will see. Okay, there is no point. Okay, construction of transformer is there. Okay, I will see if I miss anything in the first. I will see if I miss something point in the first, I will cover the next. Okay, see, one point is there I have missed here. The point is, laminated steel core transformers are used in power application. Okay, this is also one of the point. The question will come in the exam. Which transformer used in power application? Okay, which transformer used in power application? The answer is laminated steel core transformer. Okay, laminated steel core transformer are used in power application. Okay, this is the important point. You have to remember this point also. Okay friends, now up to here this is completed. There is no doubt here. Okay, we go next to the next topic. What is construction? Okay, transformer construction. See here. So in transformer construction, the important point is, okay, there are two types of transformer core is there. Okay, this is the transformer construction. So number one is core type construction. Second one is shell type construction. Okay, so we can see here what is core type construction and what is shell type construction. Okay. Okay. So what is core type construction? It consists of two separate coils. Okay, this is coil 1 and this is coil 2. It consists of two separate coil, one on each of the two opposite sides. Okay, this coil is here and this coil is here, means they are opposite. Okay, I will see example. Okay, see here, this is one coil and this is another coil. These two coils are opposite to each other. Okay, one of the each two opposite legs of a rectangular core. Okay, this is the rectangular core. Okay, this type of construction we say that this is a core type transformer. Okay, this is very simple is there. The point is, what is core type transformer? Core type transformer means one rectangular core is there. Okay, two windings are there. It consists of two windings. It consists of two separate windings. Okay, this type of construction we say that core type construction. Okay friends, this is very important. This is clear. So in this topic, what is the important point? What is the important point means, see here, it's a disadvantage. In question will ask what is the disadvantage. Okay, what is the disadvantage? Okay, what is the disadvantage? Okay, what is the disadvantage of core type transformer? This question will come in the example. Okay, so the answer is, the large leakage flux associated with it. The large leakage flux causes poor voltage regulation. So the disadvantage is leakage flux. Okay, what is the disadvantage here? Core type leakage flux. Okay, this is very important point. Okay, leakage flux. Because of leakage flux, what will happen? Poor voltage regulation. Okay, this leakage flux causes poor voltage regulation. Okay, voltage regulation will poor. Okay, because of this reason, okay, because of this reason the core type transformer is not preferred. Okay, so what is the disadvantage of core type transformer? The disadvantage of core type transformer is flux leakage. Why flux leakage? Because there is a gap. Okay, see here. Okay, there is a gap between the primary winding and secondary winding. Okay, here the flux is leaked. Okay, that's why this is the disadvantage of core type transformer. So next, what is shell type transformer? Okay, what is shell type transformer? See here, I will zoom this. Okay, the two windings are wound concentrically. See here, concentrically means, suppose this is the core. Okay, if I wind the one winding and I wound another winding, okay, this type of winding we say concentrically. Okay, this is very important word, concentrically. Okay, concentrically. Okay, in shell type transformer the two windings are wound concentrically, means the higher voltage winding is wound on the top of the lower voltage winding. Okay, this type of winding we say shell type construction. In shell type construction this type of winding are preferred. Okay, that's why this type of transformer having higher efficiency. So the low voltage winding is then located to the steel. So here one important point is there. Here two windings are there. See here. Okay, this one. This is X1 and this is X2. Okay, X1 means primary winding. Okay, primary winding means low voltage winding. Okay, low voltage winding. X2 means secondary winding, means high voltage winding. Okay, this is very important. These 2 points are there. Okay, the higher voltage winding is wound on the top of the lower voltage winding, means X1 means primary winding means low voltage, X2 means secondary winding means high voltage. Okay friends, this concept this point is, I hope you understand this point. Okay, what is core type construction and what is shell type construction. So next we see here. Okay, next core may be lamination of silicon steel sheet. Okay, this is also one important point, silicon steel sheet. Okay, these cores are there now. Okay, these are the cores are there. This core is made up of silicon steel stamping. Okay, silicon lamination silicon steel sheet. It is made up of silicon steel sheet. This is very important point. You have to remember this point also. Next we go to the next point. This is also very important point is there here. Most laminating materials have an approximate alloy content of 3% silk and 97% iron. This is very important point. Okay, see here. Why? The silicon, the most laminating materials have an approximately alloy, means the stamping is there. Okay, the iron core is there na. Okay, means it is an alloy. Alloy means, the one point is there, alloy means more than one material we say that is alloy. Okay, here silicon plus iron. Okay, silicon and iron, if you combine these two materials, okay, we say that is alloy. Okay, the transformer core is made up of silicon plus iron. In the exam, the question will ask silicon is what is the percentage of silicon in transformer core and what is the percentage of iron in transformer core. The question will come in the exam. You have to tell the silicon contains 3%. Okay, then iron contains 97%. This is very important. Okay, the silicon contain 3%, the iron contain 97%. This is very important point. This point will come in the exam. Okay, next see, the silicon content reduces the magnetizing losses, particularly the loss due to hysteresis is reduced. This is very important. Okay, in exam the question will ask what is the function of silicon content. Okay, silicon content means what is the function, why silicon is added in the transformer core. This question will come in the exam. Okay, the answer is, this is very important. Okay, the answer is it reduces the magnetizing losses. Okay, it reduces the magnetizing losses. This is very important. To reduce the magnetizing losses, the transformer core, okay, the transformer core contain silicon. This is very important point. Okay, you have to remember why silicon is added. Okay, why silicon is added in the transformer core means to reduce the magnetizing losses, especially hysteresis loss. This is very important. Okay friends, this point is completed. Next, if you come down here, we can see that, okay, one more point is there. Okay, what is the point? The transformer lamination. Okay, the transformer lamination are usually 0.25 mm, 0.25 mm to 0.27 mm thick for 50 Hz operation. Okay, this is very important point is there. Here 2 points are important. So in exam the question will ask what is the thickness of lamination in transformer core. The answer is 0.25 mm to 0.27 mm. Okay, so what is the frequency? Okay, what is the frequency of the transformer? Okay, in India the answer is 50 Hz frequency. This is very important. Okay, in America the frequency is 60 Hz or more than 60 Hz. Okay, but this thickness, the 0.25 to 0.27 mm thickness is only for 50 Hz operation. This is very important point friends. So I think this point is very important. I explain this. Okay, next we will go. The laminations are coated as one side of a thin layer of varnish or paper to insulate them to each other. This is very important. Okay, in exam the question will come that the transformer laminations are there. Okay, suppose you have a document, right? You have a document, you go to the Xerox center and laminate your mark sheet or documents. Okay, what they will do, they put a paper, they put a plastic cover over your document. Okay, same here, these are the silicon steel stampings. Okay, these are the silicon steel stampings. What they are doing, the laminations are coated on one side by a thin layer of varnish. They varnish the they varnish. Okay, they varnish the one side of the lamination, or they put a paper, then why they are putting means in exam the question will come, what is the function of varnish, what is the function of varnish or paper, okay, or paper in transformer. Okay, this question will come, what is the role of varnish or what is the function of varnish and paper in transformer lamination. Okay, the answer is to insulate them. This is very important. To insulate them from each other, to insulate the lamination from each other. Okay, this is very very important, from each other. Okay, this is the purpose of varnish or paper, to insulate the lamination. This is very very important point. Okay, next go to next point. So friends, these are what is that? This is a core construction built of separate lamination, means is the I shape. Okay, E shape. Okay, these are the U shape. These are the laminations are there. Okay, so this is not important. The important is next. Okay, one more point is there here. This is the important point. Okay, stepped core transformer. Okay, in stepped core transformer, in exam the question will come like this. Okay, what is the why stepped core, where stepped core transformers are used? Okay, this question will come in the example. Okay, see here, in large transformers a stepped core arrangement is used to minimize the use of copper and to reduce the copper loss. Okay, what is the purpose of stepped core transformer? Okay, what is the purpose of stepped core transformer? Why transformer cores are stepped? Because this is the reason. Okay, to minimize the use of copper. Okay, and to reduce the copper loss. Because of these two reasons, the transformer core is stepped. Okay, stepped core transformers are where they are used. Why they are using? Minimize. Okay, this is important point. Okay, minimize the use of copper. Okay, minimize the use of copper. This is point number 1. Why stepped core transformers are used, or the what is the advantage of stepped core transformer? To minimize the copper use, first point. Second one is to reduce the copper loss. To reduce the copper loss. Okay, this is the reason 2. Because of these two reasons, stepped core transformers are used. Okay friends, this is clear. Next, okay, this is not important. So next is transformer principle. Okay, so transformer principle we will see in the next class. Okay, what is transformer principle we will see in the next class. So friends, if you like my video, please press the like button, and you have to share with your friends also. If you want to give some suggestion, please give in the comment box. Okay, you can give me the suggestion to improve my lecture. Okay friends, thanks for watching my YouTube channel.